Imagine a computer so powerful that it can solve problems in seconds that would take today's fastest computers thousands of years. This is not science fiction. This is quantum computing. To understand quantum computers, let's first look at how normal computers work. Every device you use today, like your phone or laptop, works using bits. A bit is the smallest unit of data, and it can be either 0 or 1. Everything you see on your screen, from videos to games, is built using billions of these zeros and ones. But quantum computers are different. Instead of bits, they use something called qubits. A qubit is special because it can be 0, 1, or both at the same time. This strange behavior comes from quantum physics, the science of very tiny particles like atoms and electrons. One of the key ideas behind quantum computing is called superposition. To understand superposition, imagine flipping a coin. When the coin is in the air, it is not just heads or tails. It is both at the same time until it lands. In the same way, a qubit can exist in multiple states at once. This allows quantum computers to process many possibilities simultaneously, instead of checking one option at a time, like classical computers. Another important concept is entanglement. Entanglement is when two qubits become connected in such a way that the state of one instantly affects the state of the other, no matter how far apart they are. It is like having two perfectly synchronized coins. If one lands on heads, the other will also be heads, instantly, even if they are miles apart.
Because of superposition and entanglement, quantum computers can perform complex calculations much faster than traditional computers. For example, imagine trying to solve a massive maze. A normal computer would try one path at a time until it finds the correct one. But a quantum computer can explore many paths at the same time, making it much faster at finding the solution. This power makes quantum computers useful for solving very complex problems. Scientists are using them for drug discovery, to create new medicines faster. They are also useful in climate modeling, helping us understand weather patterns and climate change. Quantum computers can even break certain types of encryption, which is why they are important in cybersecurity. However, quantum computers are not perfect yet. They are extremely sensitive and need very special conditions to work. Most quantum computers operate at temperatures close to absolute zero, which is colder than outer space. Even the smallest disturbance, like heat or vibration, can cause errors. That is why building stable quantum computers is still a big challenge. But researchers and companies around the world are making rapid progress. In the future, quantum computers could revolutionize industries like healthcare, finance, and artificial intelligence. They could help solve problems that are currently impossible for even the most powerful supercomputers. Quantum computing is still in its early stages, but its potential is enormous. It is not just an upgrade to current technology. It is a completely new way of thinking about computation. And as this technology continues to grow, it may change the world in ways we cannot yet imagine. The future of computing is not just faster, it is smarter, more powerful, and truly revolutionary. And that future is quantum.